Alright guys, so today's video is going to be about writing vertical equations of motion. This is something that you did last week for practice, but I want to make sure that you have the correct answers and you know where you messed up if you messed up. It's pretty important that you know how to write these equations, especially once we move on to finding maximum height and finding the range. It's going to be really important to know how to manipulate those equations and what they mean, so that's what we're going to focus on. I want to start by making sure everybody has the correct equations. There are two equations that you should need. And of course, my thing is messing up even though it worked right before I started recording, but that's how it goes. Alright, so there we go. Okay, so the first equation is what we call the vertical, I know my writing's bad, velocity equation. And really this is no different than it's a rearranging of the acceleration equation we had before, except we're talking about vertical motion. So the vertical velocity equation looks like this. Vy equals Vyi plus gt. Now this is really just a more specific version, a more specific form of this equation that we had previously. The final velocity equals the initial velocity plus a times t. The only difference here is that instead of we're talking about vertical specifically. So instead of talking about instead of using a, we know that vertically there is a natural acceleration for all objects. This is called the acceleration due to gravity. Now on Earth, every object accelerates downward. Of course, you know this since you were a baby. You would drop something, it would fall on the floor. In fact, you probably made a game of it. Your parents probably got it for you. And then they threw it again, and it was very funny. I know because my baby does this game with me right now. It's a very fun game, right? But you're really learning that things accelerate under a gravitational force universally. And so this number is going to change depending on where you are, depending on how strong gravity is near you, because gravity's strength changes as you move around the universe. Technically, it even changes on Earth, but in general, the average we're going to use, the number we're going to use is g on Earth is going to be negative 9.8 meters per second squared. Negative because it's down, and again, it's an acceleration. So this is your vertical velocity equation. Let's look at the vertical displacement equation, and then we'll check your answers and see what these equations look like. Vertical displacement is again just it's sort of a rehash of another. Oh, I see my pen. It says this may be dying, but I'll just try my best. Is a rehash of another equation we already saw. So it's the vertical displacement equals the initial displacement, vertical displacement, plus the initial vertical velocity times the time plus g times t squared divided by 2, or 1/2 gt squared. It's the same thing. So once again, to make sure you understand what those pieces are, this is the height, the initial height. This is, again, the initial vertical component. So I'm going to show you how to find that in just a second. And then g is, again, still negative 9.8 meters per second squared. The meters per second, the squared thing doesn't change anything. It's just a name. It's just the name of the unit. So it's meters per second squared. You don't actually square anything. You don't do any mathematical operations. It's just like my last name is King, but that doesn't mean that I get to own all the land and collect all the taxes and make all the laws. It doesn't work like that. That just happens to be my name. Likewise, you don't actually square anything. It's just the name of the unit. Now this thing here, this was in both equations. This is the initial vertical component of velocity. This is like, imagine you had something launching like this right here. Maybe the angle was 15 degrees and the velocity was 60 meters per second. This whole thing, right? This is not all going to be vertical. Only some part, right? This thing right here of that vector, right? That vector can be broken up into a horizontal and a vertical component. This is Vyi. This is what we're looking for, and this would be Vxi, which we're not going to use right now, but we will eventually use. This part is what you care about, and this is what you need to find every time. Usually we're going to use the sine. If we have an angle, we're going to use the sine of the angle. Sometimes it's going to be implied. All right, now let's look at the assignment. Oh yeah, I forgot I put these up into different problems. First one is the easiest, but I think it probably is the most confusing for a lot of people. Baseball is dropped. Let's start. We're going to write both equations. Oops, I clicked the wrong thing. We're going to write both equations. I'm going to start with the vertical velocity equation. The vertical velocity is going to be, so we're just going to plug in what we can and leave some things, we're just going to leave them as they are. So the initial vertical velocity, well, when you drop an object, anytime an object is going to be dropped, its initial vertical velocity is simply going to be 0. It has no velocity at the beginning, right? That's what it means to drop it. It means I'm holding it, and then I let go, and it's going to start to accelerate. But the moment I let go, it still is not moving. I don't throw it down or throw it up or move it, whatever. I'm just letting it go, and it's going to start to accelerate. So the initial vertical velocity is actually going to be 0. But what about this angle stuff? Will the angle matter here? Okay, here's the baseball. It's going to move down like this right here. So what would this angle be? Remember that we always measure our angles from the positive x-axis. So if this is the positive x-axis, how many degrees away is this? Now you might be tempted to say 90, and you'd be sort of correct. The convention is you measure angles, right? You go counterclockwise to measure degrees. So this is actually, if we have to go from here all the way around to there, that's actually 270 degrees. Or you could say, if you go this way, negative 90 degrees. Those are the same thing. So what does that mean? Well, if the initial velocity is 0, to find Vyi is going to be V times sine theta. So in this case, this would be 0. Okay, that should already tell you that this doesn't really matter. Times sine of either negative 90 or 270, your choice. Any way you do that, though, you should get 0 as your answer. So the vertical velocity equation is just going to be 0 plus gt, negative 9.8 times t. And if you really just want to be simple, Vy equals negative 9.8 t. That's the answer. That's what I'm looking for. What does this mean? What does this equation tells me? It tells me the vertical velocity at any time. If I put in a time t, right, this equation, if I put in a time for t, it's going to have to be in seconds because of the way the units work. But if I put in a time t, I will get a velocity back out. If I want to know how fast is this moving after 3 seconds, I'm just going to do negative 9.8 times 3. So after 3 seconds, this object will be moving negative 29.4 meters per second. Okay, let's write the other equation and see if it's as simple. And it will be pretty simple. The vertical displacement equation. Times t plus t squared over 2. Again, very similar here. We do not have yi is the height. There's no height given to us. Obviously, there probably is a height. It's not on the ground. But we don't know where it started. And that's okay. We don't care. We're just going to call wherever it began, we can call that 0, right? Because when we think of 0, we probably think of the floor or the ground. But that's kind of deceptive right now. Like, for example, right now, if I look at the floor, I'm going to say maybe 0 meters. But it's not really, because I walked up the stairs to get up here. Right? We're above, I'm on the second floor right now. So, even if I call the floor 0, which I'm perfectly fine to do, to say what's actually 0 is kind of tough, right? We have this concept of sea level, because our state is above sea level, so we're above that. So when you get to height, it's kind of tricky, but we just call it 0, right? There's no height given, so 0. Plus, well, we remember this from last time is just going to be, right? Vyi is just going to be 0 again, because we did 0 times sine theta, or sine 270. So it's just 0 times t plus negative 9.8, that's g, times t squared divided by 2. Okay, so we can simplify this a lot, right? Because we don't need to write the 0. Y equals 0. This is going to become 0. No matter what t is, no matter what time you put in, that's going to be 0. So I'm not even going to bother that. So it really just comes down to one term. Now I can take this negative 9.8 and divide it by 2, and if I do that on my calculator, I get negative 4.9. So this is just going to be negative 4.9 t squared. And that's all. That is the entire equation there. And so again, what does this tell me? This equation tells me the height at any given time. I put in a time, I will figure out what that height is, what the height of that object is at that time. I did 3 seconds earlier, I'll do it again. So if I did 3 squared times negative 4.9, I find that after 3 seconds, the object's located negative 44.1 meters below where it started. So again, these equations are powerful because they can tell us a height at any given time. But they also work the other way, and that's actually how we're going to use them in the near future. Instead of saying, okay, what is the height after 4 seconds, which I certainly could do, I might ask, when is the object at a specific height? Let's say there was a bucket down below that was at 60 meters below, and I want to know, when does this object fall into the bucket? I could do that by simply plugging in negative 60 here and solving for time. And if I can solve for time, I'll find when that object fell into the bucket. It also works on the other way around, right? I could plug in a velocity and figure out when does this object have a specific velocity. Okay, moving on to the second problem. A baseball is tossed straight up at 3 meters per second. I'm going to have to do that on every one of these. I forgot because I was typing earlier, so it's on the type function. I'll have to switch it. Okay, baseball is tossed straight up at 3 meters per second. Again, we're going to find the two equations, Vy plus GT. All right, so I want to look at this scenario here. We've got a baseball that's tossed straight up in the air. So let's talk about angles real fast. Here's my baseball. It's supposed to be straight up. What would the angle of that be again from the horizontal? And of course, this time it would be 90 degrees. So when we find this vertical component, we have to use that 90 degrees, right? So what I'm saying is Vyi is going to be V, the original velocity, times the sine of the angle. In this case, that would be 3 is the velocity times the sine of 90. And if you put that in, and this is a good point to mention, you must be in degree mode. So on my calculator, I have a button called mode. It might be under math function on your calculator, or mode. There may be a mode function. I can help you find it if you need to. But you must be in degree mode. DEG must be highlighted. So when you type in sine, if you type in 3 times sine of 90, you should get 3 back out. If you get anything other than 3, you're in the wrong mode. So 3 times the sine of 90 is going to be 3, of course. You just get 3 back out. So then the vertical velocity equation is just going to be 3 minus 9.8t, or plus negative 9.8t. It means the exact same thing. So either way you think about that, it's the same. That's the equation. Sorry, let me write it all out together. Vy equals 3 minus 9.8t. So once again, once I have this equation, if I want to know what is the velocity after 8 seconds, I simply plug in 8 right there and I know its velocity. Likewise, and eventually what we're going to do is we're going to want to know when is the velocity 0. And so to do that, I would plug in 0 for Vy and I would solve for t. That's in the near future. Okay, what about the other equation, the vertical displacement equation? Yi plus Vyi times t plus gt squared over 2. Okay, so in this case we get the initial height is again not given to us. So once again we're just going to put in 0 plus Vyi is still going to be just 3 times t plus negative 9.8 t squared divided by 2. Okay, so hopefully you're catching on here and you caught this earlier. This term is pretty much always going to be the same. This term is always negative 9.8 t squared divided by 2, which means we can always simplify just to negative 4.9 t squared. So you might want to get a habit of just writing that, because unless the only exception to that would be if we're doing a problem that's not on Earth, like if we're doing a problem that's on Jupiter or Mars or Venus where the gravity is different. Otherwise, that last term is always just going to be negative 4.9 t squared. So putting it all together, we get y equals 0, so I'm not going to write it. 3 times t minus 4.9 t squared. That's our final answer. So one more time, I put in a time, I'll get the height at that time. All right, moving on to 3. And we'll go much faster now that we've covered the basics. So this is another example where baseball is tossed straight up. So it's almost exactly like the last one. So once again, if the baseball is tossed straight up, we know the angle is going to be 90 degrees. So to find that vertical component for this one, right, VYI would be 4 times the sine of 90, which again, if you remember from last time, it's just going to be 4. So I can almost just write this one out. Vy is going to be 4 minus 9.8 t. There we go. No problems. Vertical displacement equation, y equals. This time we do have an initial height, and since it's from a height of positive 200 meters, the height could be negative if it was below, but obviously this is above, so it's just going to be 200 plus 4t minus 4.9 t squared. And that is the equation. So one more time, what does this equation represent? It represents the height at any given time. You put in a time in seconds, and you will get the height back out in meters. And you can even start to do a little analysis here, and you can start to see what kind of path this thing is going to take, right? Because it's going to start out pretty high up at 200. It's actually going to be rising at the very, very, very beginning, right? Because this is 4t, so it's going to keep going up. But then this negative, because it's time squared, this term right here is going to start to take over pretty quickly. And it's going to quickly become, the height is going to get smaller and eventually become negative, which of course is exactly what happens. If I throw a baseball up in the air, of course, it goes up a little bit, and then it slows down the whole time, and it starts to fall, and eventually it's going to hit the ground. Okay, next question, I think is the first one where you have an angle. Model rockets launched at an angle of 70 degrees with initial velocity of 20 meters per second. So when we write the vertical velocity equation, Vy equals Vyi plus gt. When we look at this equation, Vyi, we have to actually calculate this time. We can't just probably do it in our heads. Instead, we have to find the angle. So Vyi is going to be V times the sine of the angle. Maybe on the side too much. So Vyi is going to be 20 times sine 70. Of course, just look at the units there to tell you which goes where. All right, I get 18.79. I'll just call it 18.79. So Vy is going to be, what do I have on there? Vy equals 18.79 minus 9.8 t. Great. What's the next equation? Next is easy because since we already figured out what Vyi is and it gets repeated twice, I can almost just write it out. Y equals, there's no height, so I'm just going to have 18.79 times t minus 4.9 t squared. That's your answer. And last one. Model rockets launched from a height of 100 meters, initial velocity of 30 meters per second, angle of 60 degrees. So just like last time, I'm going to calculate the initial vertical velocity here. So in this case, I have Vyi is going to be V times sine theta. So in this case, it's the velocity was 30 meters per second times the sine of 60. Sometimes people get a little confused, I think, with the height. I've seen people do like 100 meters goes here, or 100 meters goes there, but again, just pay attention to units. It's always going to be meters per second for the velocity times degrees for your angle. So I put in my calculator 30 times the sine is 60, and I get around, it's pretty much 26, but I'll leave it 25.98. Okay, 25.98. Okay, great, because again, Vy is going to go into both equations. So for the vertical displacement or vertical velocity equation, Vy is going to be, it's Vyi, which we just calculated, is 25. This pen's really giving me issues. I don't think it charged correctly. Sorry about this. Let me try to write it again. So Vy is going to be 25.98 minus 9.8 t. Pretty straightforward. The vertical displacement equation is going to be very similar. Again, it's because I've already kind of figured out part of this, I can almost write it out. Y equals the initial height here is given as 100 meters, 100 plus 25.98 times t, and then that last term is always, as long as we're on Earth, minus 4.9 t squared. So again, we're going to be using these equations quite a bit in the very near future. If you're very astute, you might notice that what we've just written here, if I rearrange it, this is a quadratic equation. When we have objects that are moving up and down, they follow a quadratic equation, a parabola, which makes sense. If I throw something, it kind of makes that shape. Well, we can mathematically show that it definitely makes that shape, because this is definitely a parabola here. And eventually, we're going to want to know when it hits the ground. So instead of plugging in a time, right now I could put in a time. You'll be asked to do that on an assignment this week. I could plug in a time and get a height. In the near future, I'm actually going to plug in a height and try to solve for a time. When does it reach that height? Specifically, we want to know, when is this thing going to hit the ground? When is it going to have a height of 0? And that'll be a quadratic formula. We'll have to use either using quadratic equation or complete the square, which are the same thing. So hopefully that makes a little bit more sense on writing those equations in motion. I know it's a little weird because you're not getting an answer. It's not like just 12 or 100.8 or whatever we're used to kind of getting. It's just an equation. But it's very, very important because, again, being able to write those equations is how we're going to figure out different things. So being able to write is extremely important. So as always, if you have any problems or confused about it, please ask. I'll be happy to help you. Thanks.